Good evening, students.
Good evening, sir.
What we are discussing? How many numericals we completed in conversion of solids? Students, how many numericals we completed in conversion of solids? Guys, please respond. Shita, Arman, anyone?
Three we completed, sir.
Frustum of cone is not there. Am I right?
Yes, sir.
Completely is not there. So anyway, for safer side, I'm going to analyze main subjects, mathematics. I'm going to share the screen and we'll discuss with respect to screen. So this is our syllabus. Second term, algebra, geometry, trigonometry, quadratic equations. Yes. We done algebra, quadratic equations, AP, circles. We have to do constructions. We are not at some applications done, surface areas. Yeah, that's it. Problems involving converting one type of metallic solid into another type of mixed problems. So that's the end of the surface areas and volumes. And frustum of cone entirely it is not there. That means this frustum of cone entirely is not there. This is not there. So don't worry about too much these things. Yeah. So we'll do some numericals today, and next class we'll start the next chapter. So 2 questions we done. Am I right? 2 questions we completed. Am I right? Or 3? Students, please respond. How many questions we completed? 2 or 3?
3, sir.
So try the 4th question. Try to depict the diagram which is representing the 4th question. Anyone understood the question? A well of diameter 3 meter is dug 14 meter deep. The earth is taken out. So just it's a flat earth. And they dug a well. How the well looks? If I'm digging a well, it will be like this. So this is the dimensions of the well is given. 3 meter in diameter and at a depth of 14 meter. Now you will get a earth, that mud and everything. So what they done, he did not make it as a waste. He embankment. The meaning of embankment means he constructed a cylindrical structure like this. He constructed a cylindrical structure around this like this. This is called embankment. Are you clear what is the meaning of embankment, students? You can see in villages how the wells looks. They will construct an embankment like this. And this embankment diameter is a width of 4 meter from a circular ring. Suppose if I am saying this is the well and this is an embankment, and it will be like this. It's like a construction. So width is like this, and embankment is up to only like this. So let's see any Google pictures you will get related to this. You can see this embankment. This is called embankment. This construction is called embankment. Hope you are clear what is meant by embankment. Shall I move to the question? So he is asking all around in the shape of a circular ring of width of 4 meter. So this width is 4 meter, and find the height of the embankment. How much height you will get? What is the logic here? The amount of the earth removed is equal to amount of the earth required to construct the embankment. First, write the dimensions. Radius of the well is given as 3 by 2 meter. Depth of the well 14 meter. So volume of the earth removed. So what is the volume of the earth removed? Pi r square h. Suppose if I am taking this is r1, this is h1. Pi r1 square h1. Pi r1 square h1, which is equal to 22 by 7 into r1 is 3 by 2 into 3 by 2 into h1 is 14. So this is 2 times, 2 cancel to 11 times. So the answer is 66. 66 meter cube of the earth is removed. So the total width of the embankment is 4 meter here. This is 3 meter and this is 4 meter. So what is the radius of the embankment? This is 4 meter width. The radius is outer radius of the embankment. Four plus 3 by 2, which is equal to 11 by 2 meter. Inner radius of the embankment. This I am taking R outer. Inner radius is equal to exactly 3 by 2 meter, which is equal to radius of the well. That is how they construct. So the volume of the earth required to construct the embankment. Volume of earth. It's look like this. Embankment will look like this. An hollow cylinder. Embankment will looks like an hollow cylinder. And this hollow cylinder will continue till end of the, and this is earth. So this is pi r naught square height of the embankment minus pi ri square height of the embankment. So this will be pi r naught square minus re square, inner radius square minus outer radius square into height of the embankment, which is equal to 66. Calculate and let me know what is the answer you are getting. Calculate and let me know what is the answer you are getting, students. What is the height of the embankment you are getting, please? 22 by 7 into R naught is 11 square by 4 minus 3 square by 4 into height of the embankment is 66. So now it is simple. So height of the embankment is 22 by 7 into 121 by 4 minus 9 by 4 is equal to 66. 22 3 times. This will be 3 into 7 by 121 minus 9. 120 minus 9 is 112 by 4. So the height of the embankment is I'm getting a little bit strange answer. Check. Anyone is getting? What kind of answer you are getting? 22 into 3. The answer should be 9 by 8. But I'm getting 3 by 4. Where we are missing, check. Pi 11 by 2 whole square minus 3 by 2 whole square is equal to pi 3 by 2 whole square into 14. This is 22 by 7 into 9 by 4 into 14. Yes, here we missed. It's not 66. Pi r square h. 3 by 2 into 3 by 2 into 14 to 7 times. 22 by 7 into 9 by 4 into 14. 7 2 times, 2 2 times, 2 11 times. So answer is 99. Sorry guys, here is wrong. 99 meter cube. So when it is 99, your answer is a little different. What is the final answer? 11 2 times. 11 9 times. This is 7. So 9 into 7 divided by 121 minus 9 divided by 4. This is 9 into 7 into 4 by 112. 428. 7 4s. Again is mistake. Guys, please try. Let me know what is your answer you are getting. I'm getting 9 by 4. 9 by 8 should come. Students, Sanyu, anyone? Harita? Will you check the answer one more time? Volume of the earth before removing is pi 3 by 2 whole square into height depth pi 11 by 2 whole square minus 3 by 2 whole square into height of the embankment. So pi cancel. This is 9 by 4 into 14 is equal to 121 by 4 minus 9 by 4 into height of the embankment. So height of the embankment is 121 minus 9, 112. So 9 by 4 into 14 into 4 by 112. So 4 cancel. 7 2 times. 7 1 is 7. 4 2. 6 times. 2 8 times. Now I am getting proper answer. Somewhere we missed in the previous calculation. So 9 by 8 meter is the answer. So 1.125. 1.125 or what? 1.125 meter is the height of the embankment. Sorry guys, please look into the calculation. If you are getting 1.04, not 04 Harita, 1.125 is approximate, not even approximate, exact answer. Look into this calculation, the previous calculation, somewhere we missed something. You have to get 9 by 4. But we are getting 9 by 8 is the final answer, but we are getting 9 by 4 there. Yes, this 2 we missed. Into 2 is there. This 2 is there now. So this is 9 by 8. 121 minus 9 into 2 is there. Numerator is 2. Yes, I will do the calculation again. Might be you will get properly. This will be 2 by 7. This will be 121 minus 9 by 4 is equal to 11 2s, 11 9s, 9. From here, h is equal to 9 into 4 into 7 divided by 112 into 2. 2 times, 2 5s, 6 times, 7 8 times. So this is also correct. 9 by 8 meter, which is h is equal to 1.125 meter. Yes. Sorry students, little confusion in calculations. Yeah. Yes. Moving to the next one. Shall I move to the next one, students? Anything confused too much here? I can move to the next one. Guys, please respond. Can move to the next one. Yeah. 51. container shaped like a right circular cylinder having the diameter 12 centimeter. A container shape is like a container which is looking like a right circular cylinder. It is like this. It's a container. And its diameter is 12 centimeter. Height is 15 centimeter. Is full of ice cream. The ice cream is to be filled into a cones of height 12 centimeter and diameter is 6 centimeter. So this ice cream they want to fill with a cones like this, where the cone height is 12 centimeter and the diameter is 6 centimeter. Find the number of such cones which can be filled with ice cream. So it's very simple. Volume of cylinder is equal to number of cones into volume of each cone. So if I am taking this is diameter of the cylinder dcy, height of the cylinder hcy. So this is the diameter of the cone d cone, height of the cone is h cone. So volume of the cylinder is pi d by 2 whole square h cylinder which is equal to number of cones n, I don't know, 1/3 pi d by d cone divided by 2 whole square into h cone. So this will be pi into diameter of the cylinder is 12. So 12 by 2 whole square into height of the cone cylinder is 15, which is equal to number into 1 by 3 into pi into diameter of the cone is 6 by 2 whole square into height of the cone is 12 centimeter. Pi cancel. So this will be 144 by 4 into 15 is equal to number of cones into 1 by 3 into 36 by 4 into 12. 3, 4, 12 cancel. And when it comes to here, 12 times 12 threes, 4 threes, 3 cancel. So 15 cones you can fill with the ice cream. Number of cones to be filled with the help of this container. Number of cones is 15. Is it clear, guys, what I meant? Volume in container must be equal to how many cones you are filling. Suppose if I am filling a number of cones, the total each cone volume is having some ice cream. So the total volume will be equal to number of cones into volume of the each cone. That's what I am doing. Is it clear? Students, I can move to the next one. How many silver coins? There is a cuboid. Like this. The dimensions of the cuboid is 10 centimeter, 5.5, height is 3.5. And he melted done a coins like this. So, 10 centimeter The coin is like a cylinder having very small thickness. Diameter is 1.75 centimeter and this thickness is 2 millimeter. So this is all in centimeters. So volume of cuboid before melting. If before melting it's a cuboid. Is equal to LBH 10 into 5.5 into 3.5 centimeter cube. Volume of each coin pi r square h, because the coin is looking pi 1.75 by 2 into 2 by 10, because it is given in mm, which is equal to 2 by 10 centimeter. So he is asking how many number of coins we can make from this cuboid after melting. So volume before conversion will be equal to volume after melting. Volume before melting is LPH, volume after melting is N into volume of each coin. Since N is number of coins made from that cuboid. So LBH is 10 into 5.5 into 3.5 is equal to N into 22 by 7 into 1.75 into 1.75 divided by 4 into 2 by 10. Calculate and let me know how many number of coins you can make from this. This can be written as 10 into 55 by 10 into 35 by 10 for convenience, for calculation point of view. 22 by 7 into 1.75 into 1.2 by 10. Please calculate and let me know what is your final answers. Yeah, please. What is the end value you are getting? Anyone got the answer? Anyone got the answer? I got to 400. 110 here cancel. 110 will be cancelled here. When I'm looking into 11 5 times, 11 2 times. Now my n will become like this: 5 into 35 into 7 into This is 2, this is 2, 4 cancel. Divided by 1.75 into 1.75. Yeah, this can be written as 5 into 35 into 7 into 100 into 100 divided by 175 into 175. 535 times 5 3 is 15, 5 5s 35, 35 cancel. 5 into 35 is 175. 7 2 is 14, 7 5s 25 4 times. So 4 into 100 is the finally remaining out of all cancellations. So number of coins is made from that cuboid is 400. Carefully you try the calculation. If anything is like, if you feel this is not the correct answer, we can check one more time. If you okay, we'll move to the next one. Please, students, please let me know. Shall I move to the next one or not? Shall I move to the next one? Guys, yes or no?
Yeah.
Yeah. How many silver coins we done? We have to go for 7th one, it seems. Yeah. A cylindrical bucket of 32 centimeter height. A cylindrical bucket 32 centimeter high and with radius. A cylindrical bucket of 32 centimeter high with radius of base 18 centimeters is filled with sand. This bucket is emptied on the ground with a conical heap of sand is formed. The height of the conical heap is 24 centimeters. Find the radius of this. It's a very simple question. A cylinder is converted into cone. The cylinder, sand is in the form of cylinder of the dimensions 32 centimeter height and 18 centimeter radius. This is radius of the cylinder. This is the height of the cylinder, and he converted into a cone. It just poured on the ground. It will form a cone. Heap of the cone. Conical heap radius we don't know, but height of the conical is 24 centimeter. So this is volume before conversion is in the form of cylinder. Volume after conversion is in the form of cone. So volume of cylinder is equal to volume of cone. So this is pi radius of the cylinder square into height of the cylinder is equal to 1/3 pi radius of the cone square into height of the cone. We need the radius of the cone here. That's what he's asking. He is asking what is the radius and slant height. So we can calculate the slant height once we got the radius. So the slant height is equal to, slant height is L. The symbol for slant height is L. root of h square plus r square. Height of the cone and radius of the cone. So pi, radius of the cone is 18 square, height of the cone is 32. చెప్పండి ఎవరు ఉన్నట్లా radius of the cone is r cone square into height of the cone is 24. Yeah, please solve this question. Let me know what is your answer. What is the radius of cone you are getting? First find out the radius of the cone. 3 8 times pi cancel, 8 4 times. So radius of the cone square is equal to 18 square into 2 square. From here without multiplication, radius of the cone is equal to 18 into 2. So 36 centimeter I got. Anyone got the same answer or any kind of different answer? Students, got the same answer? The radius value is the same. Slant height L is equal to radius of the cone square plus height of the cone square. That is equal to 36 square plus 24 square. $1,296 plus 576. 496 plus 576, which will be, it is 12 square, 12 into 3 square plus 12 into 2 whole square under the root. I can take 12 square common into 9 plus 4 under the root. The answer is 12 root 13 centimeter is the slant height. The answer is 12 root 13 is the answer. Or you can keep it in, this is a standard format, or if you are unable to get 1872 under the root. Both are correct answer. 1872. 144 into 13. Anything is fine. Students, if you are clear, I will move to the next question. Next question is a little bit important, which is having a little bit scope for the examination. Is it okay? I will move to the next one. Shall I move to the next one? Yes or no, students? Guys, Akshita, Harita, Sanyu. Yeah. Water in a canal of 6 meter wide and 1.5 meter deep is flowing with a speed of, there is a water in a canal. The canal is like this. Assume in 3D it looks like this, but I assume it is like a rectangular shape, open cuboidal shape, and the water is flowing in this canal, the open channel. So water will flow like this. Water is flowing like this, and it's saying 6 meter wide. This is a 6 meter wide and 1.5 meter depth. 1.5 meter depth. It's a depth of the canal is, and moving with a speed of, the water is moving with a speed of 10 km/h. In 1 hour, the water will flow 10 km. How much area it will irrigate in 30 minutes? How much area it will irrigate? That means if the water is flowing for 30 minutes, means it will move 5 kilometers. So 500 meters it will travel. So we can write like this: width of the canal 6 meter, height, depth of the canal 1.5 meter. Speed of the water. km/h. That is 10 into 1000 meter per hour. If I am converting into meter per minute, if I am converting into meter per minute, 1000 by 6 meter per minute, because the standard dimension should be in meter per minute, because he mentioned it is 30 minutes it's flown. So the volume of the water in 30 minutes, volume of the water in 30 minutes will be equal to time in minutes, time into volume of water in 1 minute. So 30 minutes it is flown. Like a pipe is releasing water and the diameter of the pipe and is given. So 30 minutes it's flown, and volume is area of cross section of the canal into how much speed. This is important. AV, this is area into velocity, and this is the time. So velocity is 1000 by 6 meter per minute. So 6 cancel. So this will be 30 into 1500, which is giving 45,000 meter cube. 45,000 meter cube of water is flown in 30 minutes. So with this much of water, he is irrigating the fields. How to fill the fields? He want to fill the fields in such a way 8 centimeter standing water is needed. So this is this much of area he is irrigating, and he want to fill the water up to 8 centimeter. So how much area? So area is A. So total volume is equal 45,000 is equal area into 8 by 100 is the volume of the water required to irrigate, because 8 is the centimeter. From here, area of the field should irrigate is 45,000 into 100 by 8. We'll get 425 times 4 twos. 5,62,500 meters square area of the field can irrigate in 30 minutes. Hope you understand what I done. Anyone not clear, please let me know. Is it clear, students? Shall we move to the next question? Guys. I will share a worksheet by tomorrow. Please try to solve the worksheet also. And we will discuss some extra numericals if you are having any, or we will start the probability concept next. A farmer connects a pipe of internal diameter 20 centimeter. There is a diameter 20 centimeter is an internal diameter, and canal into a cylindrical tank. There is a cylindrical tank. And her field, so 10 meter in dia, 2 meter in deep. It's a big one. Water storage. So the diameter of the cylindrical tank is 10 meter and depth of the cylindrical tank is 2 meter. If water flows through the pipe at 3 km/h, how much time will the tank to be filled? The previous formula here to use. Radius of the pipe. Radius of the pipe is 10 centimeter. That is 10 by 100 meter, 0.1 meter. Converting everything into meter. Area of cross section pi r square. Area of cross section of pipe. Pi r square, which is equal to 1 by 10. So pi by 100 meter square. Pi by 100 meter square. The next one is volume of the water flow through. Volume of water flow through pipe in 1 minute. So AV, area of the pipe into volume of the pipe, velocity of the pipe per minute. So speed of the water, we can write here. Speed of the water is 3 km per hour. That is 3000 meter per hour. That is 3000 by 60 meter per minute, which is giving 50 meter per minute, which is giving 50 meter per minute. So speed of the water in minute is 50 meter per minute, standard unit, because he is asking how much water will take. We are calculating the answer also in minute. So now volume of the water flows through in 1 minute is, velocity is 50 meter per minute, pi by 100 is area. So area into velocity of the water will give pi by 2. Pi by 2 meter cube in minute. Now, if water is flowing in t seconds, total volume of, this is in 1 minute, total volume of water can flow in t minutes is equal to pi by 2 into t meter cube. This is the volume of the water flow in 1 minute is pi by 2 meter cube per minute. In t minutes, multiply with t minutes. So volume, see, this amount of the water is using to collecting in this cylinder. So volume of the water flown in t minutes, because how much time is required to fill this? Volume of water flows in t minutes is equal to volume of the cylindrical tank. This will be pi by 2 into t is equal to pi r square, radius of the cylinder into height of the cylinder. Radius is pi square into height is 2. So pi cancel. So the time is pi square into 2 squares. This will be 25 into 4. It is taking 100 minutes. So it will take 100 minutes to fill the cylindrical tank with that much of speed using that pipe. So the diameter of the pipe is also important, and the speed of the water is also important going in that pipe. So this is how in irrigation they will calculate and they will estimate in floods using the canals how much time it will take to reach particular places and to construct the dams, to construct the canals. Krishna. Is it clear, students? Anyone having any doubts? So I will share some worksheets. Please go through the worksheet. Any doubts? Please let me know. If you want to do any extra numericals also, we will do before going to the next topic. The next topic we are going to discuss might be in probability. Statistics we already completed in first term. According to this term, it is surface areas and volume completed. We have to do statistics. Sorry guys, mean, median, mode of the group data, mean by direct method and assume mean method. We'll do statistics or circles. Any one thing we will start. I will check what is the schedule. We'll go accordingly. Is it clear? Shall I wind up the session? Harita, Amrita? Guys, yes or no?
Yes, sir.
Yeah. Bye everyone.
Thank you, sir.
Thank you, sir.